Okay, now we're on the polynomial and inequalities. Actually, this is a rational inequality. So actually 5.4 included both the polynomial and the rational inequalities. So there's actually one more part to this section. It had both parts in this. So back in 5.2, 5.3, that's where we talked about the rational functions at. So this is actually coming out of 5.3 because that's where we drew the graphs at. And this is when I had a little acronym that I did. I have a coat with hose. And so f of x equals 3x plus 6 over x minus 1. So I found the x-intercepts. That's the I on the I have a code. And x-intercepts are at -2, set the numerator equal to 0. And to find the y-intercepts, you set 0 equal to x. So it would be 6 divided by -1, which is -6. So then the horizontal asymptote would be 3 because the leading coefficients divided by each other is 3 divided by 1. And so there's a horizontal asymptote at 3. And what that basically means is that what the graph actually gets very close to at the ends. So if you notice, the graph is getting closer to 3 at this end and 3 at this end. That's what the horizontal asymptote is all about. The vertical asymptote is where it's undefined. And x equals 1 is where that's going to be. So then does it cross the horizontal asymptote? If you remember, if you're in class, I told you guys linear over linear never does cross the horizontal asymptote. But if you didn't know for sure, you'd set that equal to 3 because that's what the horizontal asymptote is and solve for x. In this case, it wouldn't give you an answer. You'd get something like 6 equals -1, and that would be untrue. No obliques on these graphs, and then you're ready to trace it. So you got these two x-intercepts here and here, and you just remember it gets magnetized towards the asymptote, so it's magnetized at this end, magnetized at this end. So, but it's got to be up here because it's got to be magnetized. It goes through here and it crosses because 3x plus 6 have an odd degree exponent. So it goes down, goes to the next intercept, the y-intercept, and then becomes magnetized from the bottom side. Some people say, well, why can't it just turn back around and go back up? Because you'd have to have another x-intercept between 0 and 1, which you do not have. So this is the only choice it could be. It ended negative, so it started positive, and most of the time that's going to happen to you guys. The reason it does is because the exponent on the bottom is a 1, it's odd. If that had an even degree out here, like x minus 1 squared, it'd be on the same side. Most of the time it's like this though. So, and then it ended negative and it started positive. And I had like a 4 or 5 part series before this when I was graphing rational functions before. So this is just one of those ideas. Now in 5.4, we have problems like this. So it's going to know when is 3x plus 6 over x minus 1 less than or equal to 0. So what this is asking is where it's below the x-axis, not above. So where is it below the x-axis? And it's above on the left side of -2. It's below between -2 and 1. And it's above again on the right side of 1 because it's above the asymptote. And if it's above the asymptote, it's above the x-axis in this case. So looking at the graph itself, the solution will be between -2 to 1. Now that's not quite the answer because the -2, it says less than or equal to 0. -2 is actually part of my answer because it says less than or equal to, and -2 is an x-intercept and it's on the x-axis. So that one does get a bracket. And sometimes you get kind of, you get in a rut and you want to do, well, if it gets one here, it's going to have one on this one as well. But that's not true. Even though it says less than or equal to, it's not, a 1 is not included because that 1 is a vertical asymptote. It's undefined at that place. It can't be equal to 0 because it's undefined. So that one stays in parentheses, although it does say less than or equal to. So you just can't put those together and say less than or equal to always gives you brackets. You got to use your noggin a little bit on these things. So -2 to 1. That should be my answer. Okay. Now, like I was on doing some problems a while ago, you always don't want to just have to draw the graph because, I mean, I have a coat with holes. That one's a pretty long procedure of how to do these problems. So at least, hopefully, when I'm graphing rational inequalities, I won't have to go through the whole process just to pick off where is it below the x-axis. So what I'm going to try to do is I'm going to try to do this whole problem without the whole graph. So what I'm going to do is just draw the x-axis. Okay, and similar like we did a while ago with the polynomial inequalities, I'm going to find the x-intercept. So the x-intercept is -2 on top. The difference is also I got to find vertical asymptotes. So basically what you're doing is setting the top equal to 0 and the bottom equal to 0. Locate those points on your number line. Because at -2 is an x-intercept, you notice it crosses from the positive to the negative, goes from one side to the other side. Because that's what you're interested in, is where it goes from one side of the x-axis to the other side. But that also happens at vertical asymptotes. Negative back to positive. So at 1, we also have to be concerned about. So rational inequalities, you got to be concerned about two things: the x-intercepts and vertical asymptotes. Whereas on polynomial inequalities, it was just the x-intercepts because they didn't have vertical asymptotes. So -2 to 1. Now, again, a lot of teachers teach it this way. They teach it as if they just plot point. They just put points in. You could have done that a while ago with polynomial inequalities as well. You could plug a number in, see if it's above or below, and put a number between -2 and 1, like 0, and put it, see if it's above or below. Same thing on all of them, and detest each region. And that, to me, takes too much time. So the rational inequalities, I'm just going to begin with that in behavior, just like I did with polynomial inequalities a while ago. So the 3x plus 6 over x minus 1, what is the in behavior? Well, it's not left arm up, right arm down, or both arms up. It's leveling off on this one. But it's leveling off above the x-axis. So what you want to be concerned about is the horizontal asymptote as well. Horizontal asymptote is 3, and 3 is positive. That's above. So it's above on this side, and it's above on this side because it's at 3. As a matter of fact, it's 1, 2, 3. It's way up here, actually. But it's above. And these cross because it has an odd degree, so it's down here between -2 and 1. And then this is a vertical asymptote with an odd degree, so it goes back up above it. So above, below, above. And you're looking for the below part. So you're looking for between -2 and 1, just like we talked about a while ago. And again, 1 is not included because that's a vertical asymptote. -2 is included because it's an x-intercept, and x-intercepts are included because it's less than or equal to. And so that's the solution between -2 and 1. Now, it's easy to do these problems when you're sitting there staring at the graph. But, can we just draw the graph and do that? Well, you can, but that takes too much time. And you're not going to have a whole lot of time to take the test. So you want to just kind of skim through this x-axis only. Because let's worry about the graphs when you have to do those. It says graph this rational function. The I have a coat with those. Worry about those problems when you have to. So you got to find out amount of time here. You don't have a whole lot of time. So this little technique right here is just because all you're really concerned about whether it's above or below. So you don't have to go through all the I have a coat with those. You don't have to go through the whole procedure and tracing the graph and everything. Really, the only thing you got to worry about is the x-intercepts, the vertical asymptote, and really the horizontal asymptote, because the horizontal asymptote is going to tell you the in behavior of where it's going to be. So I'm going to work 2 more examples with the rational inequalities.